Hello everyone, welcome to Physics 101. I'm Mr. David Carter. Today, we're going to learn Newton's first law of motion. Don't worry, it's much easier than it sounds.
By the end of this lesson, you'll understand Newton's first law, learn what inertia means, and recognize it in everyday life.
An object at rest stays at rest, and an object in motion stays in motion unless acted upon by an unbalanced force.
This is Newton's first law. It tells us that objects don't change what they're doing unless a force makes them change.
Key term 1, object at rest. An object at rest is simply an object that is not moving. A book on a table is a good example. The book stays where it is. It won't move by itself. Someone has to push it first. The second important key term is object in motion. An object in motion is something that is already moving. It will keep moving in the same direction unless another force changes its motion. Imagine you kick a soccer ball. The ball rolls forward. It doesn't suddenly stop for no reason unless someone stops it.
A force is simply a push or a pull. Forces can make objects start moving, stop moving, speed up, slow down, or change direction. Another important term is friction. Friction simply means a force that opposes the motion or attempted motion between two surfaces that are in contact. So why does the soccer ball eventually stop? It's because of friction from the ground that pushes against the ball and slows it down. Another important term is inertia. Inertia is an object's natural tendency to resist changes in its motion. Remember, every object has inertia. For example, when a car stops suddenly, your body keeps moving forward because of inertia. That's why wearing a seatbelt is so important. Newton's first law is happening all around us every day, even if we don't notice it.
Let's review. Objects naturally resist changes in motion. Forces change motion, and inertia explains why.
Excellent work today. Now you've learned Newton's first law and the meaning of inertia. Let's move to another simple topic, that's measuring motion.
But here's an important question. If an object is moving, how do we describe its motion?
And how to know how fast it is moving. How far did it travel, and how long did it take? Today, we're going to answer those questions.
By the end of this lesson, you'll know how to measure motion using distance, time, and speed. You'll also learn your very first physics calculation.
Motion means an object changes its position over time. If something moves from one place to another, we say it is in motion. Now you understand what motion is. But knowing that something is moving isn't enough. Scientists want to describe motion more accurately.
So our next question is, how far did the object move? To answer that question, we use a quantity called distance. What is distance? Distance is the total length of the path traveled by an object, regardless of the direction. It tells us how much ground an object has covered. Great, now we know how far the object traveled. But there's still one important question. How long did it take? To answer that, we measure time.
Time tells us how long the motion takes. We measure time in seconds, written as s, or sometimes in minutes and hours.
Excellent, we now know two important things. First, we know the distance. Second, we know the time.
But can these two measurements tell us how fast the object was moving?
Yes.
Yes, they can.
Yeah.
And that brings us to the next concept, speed. In simple terms, speed tells us how fast something moves. Now let's combine distance and time together and see how objects speed.
Now that we understand what speed means, the next thing is, how do we calculate it? In physics, we calculate speed by dividing the distance traveled by the time taken. So remember this simple formula, speed equals distance divided by time. This formula will be one of the most useful formulas you'll learn in physics. Physicists usually write formulas using letters instead of full words. So let's learn what each letter means.
V stands for speed, D stands for distance, and T stands for time. Whenever you see V, D, F, T,
just remember it means speed equals distance divided by time. Now, let's solve this example using this formula. Don't worry if you've never solved a physics problem before. We'll solve it together, one step at a time. So in this question, we're only looking for speed. To solve that, first write the formula. Next, replace the letters with the values we already know.
Distance is 100 meters. Time is 20 seconds. Now divide 100 by 20. So the answer is 5.
Distance equals 240 meters. Time equals 30 seconds. V equals what? That means the object travels 5 meters every second. Great job. Let's try another example.
The second example says, if distance n is 240 meters and time n is 30 seconds, then what speed v then?
This time, I'd like you to think about the answer before I solve it. So using the same formula, divide 240 by 30. The answer is 8. So the object's speed is 8 meters per second. Notice that we followed exactly the same steps as before. Once you learn the formula, every problem becomes much easier. Let's look at some real-world examples. So far, we've solved numbers on the board. But physics is all about understanding the real world. A cyclist riding on a road. Imagine a cyclist travels 120 meters in 20 seconds. What is the cyclist's speed? To solve this, we divide 120 by 20. The answer is 6 meters per second. This is exactly how scientists, engineers, and even athletes measure speed. Excellent. Now, let's review what we've learned recently.
First, motion means a change in position. To describe motion, we measure distance, which tells us how far an object travels. We also measure time, which tells us how long the motion lasts. Finally, we combine distance and in our next lesson, we'll learn how to calculate distance and time in a simple way. Enjoyed this lesson? Please subscribe to Condensed College and turn on notifications so you don't miss our next class.
All right, students, that's all for today. See you next time at Condensed College. Goodbye.